These two figures, they look very intimidating. But then I want to show you a way that you can always use to answer these kind of questions. So before we even approach this question, let me give you a few tips, right? So tip number one is that you have to try use trig ratios, right? So trig ratio, what do I mean by that? The first thing you should do is to see if you can use sine, cos, or tan to do that. And then if that doesn't work, you have to move to Pythagoras, right? So you have to move to Pythagoras. And then if Pythagoras doesn't work, you can then use the sine rule, right? So we have sine rule. And lastly, if the sine rule fails you, you can use the cosine rule, right? So because people sometimes they're confused. What am I supposed to use? Should I use the sine rule? Should I use the cosine rule? This is the way you should do it. You start by trying to use the trig ratio. If it doesn't work, you use Pythagoras, the sine rule, and the cosine rule. So let me apply this to this question so that you can see that it works perfectly. So the first question here, we have 8.1. Let's calculate the length of AB. So we have, let me just highlight AB real quick. So here we have A, here we have B, right? We're looking for this length right here. So let's look at our first attempt and see if we can answer the question. So what we should do first is use trig ratios. So can we find AB using trig ratios? Let's see if we can do that. We have this angle here, right? And then we have the opposite side and we have the hypotenuse, right? So it should be easy to see now that we can say that sine of theta is equals to the opposite divided by the hypotenuse, right? So now we're gonna have sine of 15 degrees being equals to the opposite. What is the opposite? What is the side opposite our angle? That is AC, which has a value of 0.5. So we're gonna have 0.5 divided by the hypotenuse, which is AB, right? So you can see here that we're gonna cross multiply. If we do that, we're gonna get AB consequently being equals to 0.5 divided by sine of 15 degrees, right? And then if you put that in your calculator, you should get AB being equals to 1.93 meters, right? So we have used a trig ratio to find the length of AB. Let's move forward and do 8.2 and see what is happening here. So 8.2 is saying that in figure 2, so figure 2 shows the top view of the ramp. The area of the top of the ramp is divided into 3 triangles as shown in the diagram. Right, and then if BAE is equals to 120 degrees, let's calculate the length of BE. So yeah, let's highlight where we are right now. This is where we are. We have BE. Yeah, we're looking for the length of BE, right? And then BE is the side on triangle BAE, right? And then it is the side again on triangle BED. But then clearly we're going to use triangle BAE because we have the most information there. We have an angle and the side, right? But then how are we going to ultimately find BE? Let's go to our 4 options and see which one we can use. We cannot use trig ratio because that is not a right angled triangle, right? And then we cannot use Pythagoras. We cannot use Pythagoras because it's not a right angled triangle again, right? For us to use Pythagoras, it needs to be a right angled triangle. And then what about the sine rule? Can we use the sine rule? Yeah, no, we cannot use the sine rule to find that side. We would need 2 angles to use the sine rule to find that side, right? So now we're only left with our 4th option, which is the cosine rule. So now we know beyond a reasonable doubt that the cosine rule should work. So let's go ahead and apply it and see what happens. So the cosine rule, by definition, it says that A squared is equals to B squared plus C squared minus 2BC and then cos of angle A, right? But then now we're not looking for A, but we're looking for BE, right? So let's have that instead. So we're gonna have BE squared being equals to one of the sides squared. So let's take AE. So we're gonna have AE squared, and then plus AB squared minus 2AE multiplied by AB, and then cos of the angle opposite the side we are looking for. So here we are interested in angle A, right? So BE, so here we're gonna have BE squared being equals to AE, which is 0.9125 plus AB, right? We calculated AB in 8.1, so we're gonna have so we're supposed to square AE and then plus 1.93, and then we also square that, and then minus 2 multiplied by AE, which is 0.9125 multiplied by AB, which is 1.93, and then multiplied by cos of angle, the angle opposite the side you're looking for, which is 120 degrees, right? So we're gonna go ahead and take square roots on both sides. So on the right hand side, I'm just gonna take everything to the power and half. That is the same as taking the square root, right? And then if you put that in your calculator, you should get BE being equals to 2.52 meters, right? And that is the answer to 8.2, right? I might have been moving a bit too fast here, so you might wanna rewind the video a bit and just watch that part again, right? Moving to 8.3. So 8.3, so let me just 8.3 is saying that let's calculate the area of triangle BFD. So let's just highlight BFD first before we continue reading. So BF and then D, right? We know that BF is equals to FD. It is given to us, and then okay, let's carry on reading. If angle BFD is equal to 75 degrees, that is there on our sketch, right? It is indicated on our sketch. And then BF is equal to FD, like we've already established, and BF is equal to 5 divided by 7 BE, right? So before we can do any working, I just want to show you something. The area of a triangle, right, is equals to a half side 1 side 2 sine of the angle the two sides sandwich, right? Yeah, it is just that with the right angle, the triangle, you use the sides that sandwich the angle 90 degrees, right? And sine of 90 is 1, so that's why you just say half base multiplied by height. But then really the area of a triangle is half side 1 side 2 sine of the angle the two sides sandwich, right? So here, if we determine the length of BF, right, and the length of FD, then we can say BF multiplied by FD and then sine of this angle here, which is 75 degrees, right? Yeah, so now our task really here is to find the length of BF, but we know that BF is equals to 5 divided by 7 BE, right? What is BE? We calculated BE in 8.2. It is 2.52, right? And then if you put that in your calculator, you're gonna get 1.8 meters, right? So now we have the length of BF. So we can go ahead and say that the area of triangle BFD will be equals to a half BF multiplied by FD and then sine of angle F, right? And if we substitute that, we're gonna get a half multiplied by 1.8 multiplied by 1.8 again, because we know that BF is equals to FD, and then multiply by sine of 75 degrees, right? And then if you put that in your calculator, you should get the area of BFD when it goes to 1.56 meters squared.